video is going to teach you how to count atoms. I'm going to use this worksheet that's linked in Canvas for you. We're going to start out with just a few examples here at the top. Let's review first. This first question asks you what the symbol of an element represents. So for example, if we saw the symbol Ba, we would know that that represents the symbol for the element barium. I'm going to write in red, sorry. It's going to represent barium, and that is going to represent one atom because it's just Ba by itself. There are no subscripts with it. Now, if you go on to number 2, a subscript is going to be a number written in the lower right corner. For example, you see with this Cl symbol for chlorine, we have a small subscript 2 beside it. That's used to indicate more than one atom. So when you see a symbol like that with a number, we know, of course, that Cl is chlorine, and because of the subscript 2, it represents 2 atoms of that element. It can get a little bit more complicated when the formulas are larger. For example, in number 3 here, we have the compound Ca3PO4 So when we look at that formula, we see that the calcium has a subscript 3 beside it. That tells me that there are 3 atoms of calcium. But then you see that PO4 is in parentheses with a small subscript 2 outside of that. This indicates there are multiple PO4 groups. So just like in math, we're going to distribute that 2 through the parentheses. We are going to multiply the 1 phosphorus inside the parentheses by the 2 outside, giving me a total of 2 phosphorus atoms. And then we're going to multiply the 4 oxygens on the inside of the parentheses also by the 2 outside, and that's going to give me a total of 8 oxygen atoms. So anytime you have a parenthesis with a subscript beside it, the 2 or whatever subscript you have is going to distribute through the parentheses only. That 2 does not affect the calcium here in the front. Now there's one other type of number that you'll run into when you're counting atoms, and that is a coefficient. A coefficient is a large number written in front of a formula, like this 3 that you see here in front of the carbon. When it's written in front of a chemical symbol, that will also represent the number of atoms or molecules. So for this first example, it's another way to represent 3 carbon atoms. Well, when you see a coefficient in front of an entire formula, like this one, we're going to multiply the whole formula by that coefficient. So what we see here is that there are 2 sodiums because there's a subscript 2. We're going to multiply by the coefficient of 2 to get a total of 4 sodium atoms. We're going to do the same thing with the sulfur. In the formula for this compound, I only have 1 sulfur, but there are 2 of those. So that's going to give me a total of 2 sulfurs. And then finally, I see 4 oxygens. I multiply that by 2. That gives me a total of 8 oxygen atoms. So the big difference is that the subscripts are written after a formula or a symbol for an element. A coefficient is written in the front. And you can see that the subscripts only affect the one element that they're written after, and the coefficients affect the entire formula that they're with. Okay? So here are a few practice ones. This first one, we're looking at 2 H2Os. So that means that I have 2 molecules because of the 2 coefficient in the front. I'm going to distribute that 2 coefficient in front through the entire H2O formula, meaning I will have 4 hydrogens, and then if you count your oxygens the same way, you will have 2 oxygens. The next problem, we have 3 Na2SO4 molecules. So the coefficient tells me I have 3 of those molecules. Each one of the molecules has 2 sodiums because I see the 2 subscript next to the Na symbol. So I have a total of 6 sodium atoms. I have a total of 3 sulfur atoms, and I have a total of 12 oxygen atoms. I multiplied the subscript for sulfur and for oxygen by the coefficient 3 to get those totals. And finally, I have 4 molecules of PbNO32. That means I have 4 molecules of PbNO32. That coefficient of 4 is going to affect this entire molecule. There's only 1 lead in the formula, but I have a coefficient of 4, so I have 4 lead atoms. There's 1 nitrogen inside the parentheses. I'm going to multiply by the subscript 2 outside the parentheses, and then I'm also going to multiply by the 4 coefficient in front, giving me a total of 8 nitrogen atoms. And I'm going to do the same thing with oxygen. I have 3 oxygens inside the parentheses, multiplied by the subscript of 2 and the coefficient of 4, which will be a total of 24 atoms of oxygen. 3 times 2 is 6, times 4 is 24. So that's how you count atoms in a variety of formulas using subscripts and coefficients. The next section on this worksheet is a set of problems for you to practice. Good luck!